GM. Welcome to what's going to be another fantastic episode of DevNTell. So, if you didn't know, DevNTell is a 30-minute podcast allowing founders, hackers, and anyone in between the opportunity to come on the podcast and showcase what they built. And today, I'm ecstatic to welcome João Garcia, who is the lead developer advocate at Cartesi. So, if you didn't know, Cartesi enables developers to build Appchain rollups with any code. That's any programming code, while benefiting from the security of Ethereum. So, if you stick around for today's episode, you'll get to meet Joao, learn about Cartesi, and how you can get started with them today. All right, let's get into it.
Hey,
Hey,
GM.
hey, GM. How you doing, Joao?
I'm good. What about you?
I'm doing well as well. Thank you so much for joining us on this Wednesday. I know it's a little busy this time of year, so really happy to have you on today, man.
Yeah, everyone in a rush for the holidays, but always good to have some space to breathe and talk a little bit.
Exactly.
Thank you for having
Uh,
me.
Of course, my pleasure. Yeah, I've been digging a little bit into Cartesi, and it looks really dope. The fact that you can use almost any programming language to build smart contracts is a pretty neat concept to me, and I'm sure our audience as well. And I guess before we get into all those details, would you just like to give a brief introduction about yourself?
Yeah, sure. My name is João, as you mentioned. I'm developer relations lead for Cartesi, developer advocacy lead. Um, so I've been working in Cartesi, I think, for a little more than a couple of years now. I've been working with crypto a little while before that. And it's been a real nice journey. I think quick things about me. I'm a I love all nerdy things. I'm a tennis player. As you can see from my background, I love Lord of the Rings, I
Love it.
think you too, right? So yeah, that's me. That's essentially me.
Awesome, man. Yes. That I didn't know. I didn't know there was a extra Lord of the Rings element on the show today. Excellent.
Yeah, exactly.
um, yeah. I guess. Just curious. Like, how did you find yourself in the technology sector, and like what kind of led you to Cartesi?
Yeah, I think since small, I had this tendency to the computer itself. My father worked with IT, and he was a developer. Then he started on managing positions, but always very, very, very connected to technology. And so when I went to university, I was between technology and architecture, and I just think, I don't know, technology had a better market than architecture, right? And I really found myself in university. I started in computer engineering, then I moved to computer science. I had a very cool Apple opportunity internship, Apple Developer Academy, and there I met some friends who are my friends to this day and who I work with to this day, which is really, really nice. And yeah, that's how I started developing. And these friends are actually the ones that brought me to Cartesi, right? Because we've been so close since, and they've been in crypto for much longer than I do. I mean, they've been diving in it, I think, since 10 years ago, or I don't know exactly when, but I knew that some of them started working on this project called Cartesi. So I always heard about what Cartesi was, and I think I think it was around 2023, mid 2023, that I started talking to them to get a better understanding of how they actually did things. And then I found that that's really interesting. That's a little different from what everyone else is doing. Okay, I think you have a nice path for Web3 right there. Let's try to dive heading in this thing.
Yeah, amazing, man. Yeah, I think you chose a very fascinating field to enter. Um, just curious, like a lot of people's first exposure to blockchain and crypto is through like Bitcoin and Ethereum. Was that the case with you, or was your first interest Cartesi itself, and then everything else?
No, actually, my first interest was a while ago with Ethereum, trying to understand how Ethereum worked. I remember there were some classes at university. I really tried to study to better understand it. I found it kind of limited at the time. And then in my previous work before Cartesi, I actually had the opportunity to work on a Web3 project for green energy tokenization, kind of like carbon credit, green energy credit. So I started to have to, I needed to get a better grasp for it, and then I started to see the real potential, behind the thing, you know. So it was kind of through Ethereum, but I studied lots of different technologies there to see whatever fits best. And after I was finished, then I started thinking about Cartesi, and I saw how would it have made my life easier. but the first contact was through Ethereum.
Awesome, and that this is a great segue. Yeah, I guess what is the elevator pitch of Cartesi in your own words?
I think it's enabling people to do what they are not capable of doing on Ethereum by itself. Okay, it's, of course, it works through a rollup, so it computes off chain and brings the information on chain afterwards. But it empowers the developers to do whatever they want with the technology that has been created since internet is a thing, right? So we are bringing the tools from Web 2 to Web 3 and in the best way possible, right? Oh, it depends on who we're talking to, but Linux on chain kind of sticks to some people, and then Web 2 on Web 3 sticks to some people. It varies a little bit.
Yeah, certainly does. And so the concept is essentially that you can use any programming language to create smart contracts, correct?
Exactly.
Wow.
And
Wow.
not just the language. This is very
Mm.
important because there are other protocols that allow you to use other languages. But the way we do it is running an instance of Linux inside the virtual machine that we created. That means you're not like transforming one language in another, right? More technically speaking, you're not transpiling or recompiling or doing any sort of this magic. What you're doing is you actually have a Linux environment. So anything that you can do on Linux, you will be able to do on it, which means you can also use different libraries. So you want to create a game, you can put the game engine right there. You're not just using the language, you're using the tools for it. You're working with AI models. You can put an AI library there. You are working with let's see, you're working with a very complex financial application that you need to calculate linear regression. You can use mathematical libraries that will allow you to do that instead of rewriting the whole thing, recreating the whole thing on Solidity and doing it from scratch. We're keeping it simple and just allowing you to do your best with what you already know.
Wow, that's quite the powerful construct. And yeah, like when you're describing the environment being like a solely Linux one, the first thing that popped in my head is like, oh, can I run maybe like a local AI model or something like side by side in the same container? And it's like, oh, you said it. It's like, oh, okay.
Exactly.
Yeah.
There's a teeny tiny limitation, I would say, is that the computing power of the execution environment is limited, right? As any execution environment, so you would have to scale to get better performance. When we're talking about AI models, if we're talking about general AI, if we're talking about like linear regressions, we're talking about decision trees, we're talking about many different AI algorithms, AI solutions. We have templates for many of them on Cartesi. Of course, if you want to run a full LLM, a version of ChatGPT, that's much more costly because in general, you need big GPUs and it's much harder to do. It's something that it's something that every now and then we explore and play around with, but it's deep learning, deep AI is harder to deal with.
It is, yes, and, like, the cost of RAM and GPU these days is through the roof, so
Exactly.
yeah.
Exactly.
Awesome. Yeah, I'd like to double click a little bit on some of the concepts surrounding the Cartesi EVM. Uh, Starting with the Cartesi machine, can you give us a little a deep dive into what those are?
Yeah, of course. The Cartesi machine itself is is this more powerful machine, is this more powerful execution environment. Being very technical here, but trying to be fast to not bore anyone. We created an emulator that uses the RISC-V instruction set. So it operates like a RISC-V processor, but we have to make it deterministic because in the root of Web3, you have to be able to verify the computations. So deterministic as in for every input that you send given a state, you will always have the same output, right? So you can actually see what someone processed and actually verify it. So you can attest for the truthness of the computation, right? And yeah, so this is the whole magic. And for doing that, we had to kind of make many a very complex implementation of this RISC-V instruction set. But now, in the high-level explanation, we basically created a virtual emulator that allows you to run anything, given it's a open source processor. And for convenience, we put Linux on it for anyone to be able to get ready and start coding on the go. So use a familiar environment.
Yeah, and yeah, that familiarity is huge.
Yeah.
I know like a lot of people who do start in like smart contract development, for example, they gravitate towards Solidity, and if you have like some JavaScript or TypeScript knowledge under your belt, it's a little easier to pick up. But then like once you get into the nuances of it, and you get to gas
Yeah.
golfing and this and that, and it's like, oh, it's not
Exactly.
not as straightforward as one might think. But yeah, this sounds very fascinating, and um, this concept of the Cartesian machines, they play a role in the grander scheme of things, right? With the actual rollup itself, the Cartesian rollup. Do you want to get into that a little bit
Yeah,
to tell us
sure.
about it? Yeah,
I think for that, I would like to share my screen here a little bit
let's do
to
it
get a little bit in the. Let
in the
me.
weeds. Yeah, yeah.
Yeah.
Also, don't be afraid to nerd out here. We're a bunch of developers on this show, so
All right.
get as nerdy as you want. Get as
I'll
nerdy
do
as
it
you want.
then. Okay, so talking about Cartesi, one of the coolest things that I want to show you later here is that you can actually do with Cartesi, and one of our spotlights is running Doom on chain, right? So everyone runs Doom everywhere. People run Doom on Minecraft. People run Doom on Notepad++, and people were, I think it was 2023, doubting like, hey, how come no one ran Doom on Ethereum yet? And then this guy who's a developer for Cartesi, who's crazy good developer called Eduardo. If you ever play Tibia, you might have heard of him. But he actually managed to record the whole gameplay of Doom and replay it on chain to verify the gameplay of people. So anyone can actually run a game of Doom and verify it on chain. So you can attest for your gameplays. This is very cool for speedruns and other things. So we ended up seeing like this is just a. I mean, we ended up seeing that this is just a tip of the iceberg. There is even the creation of this whole other solution that I will show later called Rives for gaming, but it's not just about gaming. So let's talk about the Cartesi machine and the Cartesi rollups, right? We mentioned the Cartesi machine. It's an execution environment and it's deterministic, right? So for every input that we give, we have to get a specific output, and that should be really, really simple. It should be obvious, and it should be just that. But when you're picking your execution environment for whatever you're developing, you have to consider so many things, like what you're optimizing for, what kinds of dApps people are going to be running. You're going to have to think what kind of languages your developers are going to be using, what kind of resources they will leverage, will they need introspection, containerization, is there a need for instant composability, right? So you run your app, you need every other app to be able to see the result of it immediately. Can you tolerate fast finality? So we created this environment, which for us, at least, it sounds like right now it is the best execution environment for Web3. We call it B. So this is our mascot. It's a B. And we think it's so good, right? As I mentioned, because of the things that I mentioned, Linux and more power in the CPU than the EVM or other environments can provide still, right? It does not use GPUs, just CPUs. So it's limited in that sense, but it's far, far better than any other option that is out there right now. So I like to think of the advantages of Linux, not only that you can run everything that has been made so far, but you are also going to be able to run everything that will be made in the future. So think of like new libs, new tools, new gaming engines, new AI tools, new mathematical tools. Everything that's going to be built that will run on Linux will run on this execution environment. So that's why it's so good, right? There's also the difference of do you know that story about the space race where people were just trying to develop this amazing pen that was able to actually write in outer space? And
Vaguely, yeah.
so they had to create this special pen that projects the ink with gravity because it wouldn't stick to the paper. And then the other team came and just used the pencil, which made it so much easier. So I kind of like this analogy, you know. EVM tooling is very flexible in the sense that you can have like a plier and you can use it for so much, and you can even hammer things with a plier, right? But there are specialized things that give you better and more specific functionalities. So we try to gather all this tooling. So you can use AI libraries like scikit-learn, PyTorch. You can use databases like SQLite on your applications. You can develop with any language, as we mentioned. And this is just one of the advantages of the solution. The other one is the way we structure it. We structure it through rollups. And it has a huge advantage because on rollups, you're computing things off-chain. So you're not competing for block space, and you're not competing for the execution environment of the EVM. So you do not make you do not have gas prices so high. You do not have all the issues that you have to over optimize on when you're developing on Solidity on a general purpose chain, right? So a transaction arrives on Ethereum, the Cartesi Appchain will get these inputs, it will process whatever, and it will settle back on Ethereum. If we think about how multiple apps work, let's say we have a gaming app chain on one side and a machine learning PyTorch app on the other side, and there are many validator nodes for each, but each of them only validate the applications that interest them. They don't have to validate everything, so they're not kind of stuck in the general purpose environment, and they work separately, and one does not compete with the other. So Rollups allows us to scale like this. Application-specific Rollups allows us to scale like this, right? Of course, you can also play around it with other protocols. So you can use a different sequencer, a different data availability layer. So you have different performance, faster confirmation times, and you can mix and match however you want, right? So these are the two key things for Cartesi Rollups: app-specific Rollups and the Linux environment that allows you to do anything without competition. So we've built some things that were very cool. I mentioned Doom already, but we built a game called Bubble Wars, which is very fun, that you pay gas to move your bubble. And if it hits another bubble and it's bigger than it, it actually consumes it. And so you get the tokens that the other guy have, right? So whenever you move your bubble, it's trying to eat your other bubbles by paying tokens, but you can always get more tokens because you're eating someone else. So it becomes a kind of like a crazy degen massive multiplayer game. Have you ever played SimCity? I think
Yeah.
everyone played SimCity. We actually managed to put it on chain as well, so people can create their own cities, and you deposit some tokens to start playing, and if your city makes money, you make money. If your city loses money, you lose money. That's also very cool, and it's actually a real use case. We have some social applications as well. Co-writing, where you can actually share the revenue with different proportions, and this calculation can only be made, of course, because of the complex computations that the machine can process. Or even a drawing canvas, where you can actually check for the steps in the drawing of the person, so you can actually see that the NFTs that you're minting were created in the platform. You can prove the creation of the NFT, not only mint it, but mint it with the whole history of the drawing, which is very fun as well. And of course, some machine learning templates, as I mentioned, biometrics classifier, iris classifier, which are very common data sets. Lilium, that a friend of mine built, which is for carbon credit it's a carbon credit solution that uses AI to verify forests, which is very nice. And you can see much more solutions on Rollup Lab. I will show one real quick here. This is called Rives, right? It's what came from Doom that I showed. And now it has so many more games that you can play. This is my favorite one. It's called Blade Bomber. So I will just do a small playthrough of it here, and you can see the kind of complex games that you can run here. So I am an adventurer on a dungeon right now, actually killing monsters, and people are able in this application to create their own games and sell their own games, and all of these games run in a template that run in this emulator for Rives. And you can then submit your playthroughs, and it's all verified. So speedruns, contests, lots of things can happen here. And just to show how easy it is to develop here, I have this playground application, which is basically a template it's a website tutorial for you to learn how to develop with Cartesi, kind of like Crypto Zombies is for Ethereum. And you can see here, let me do some zoom in just for people to be able to read better if they are on their screen. And you can see here that there is an explanation of like, this is where your inputs come from. So whatever you send to Ethereum will hit this handle advanced function right here, right? So let me just decode the data that is coming from Ethereum. So I'm gonna do a hex to string on the data payload, and I will console.log the decoded variable. And I can just run it, and I can actually do a console log of whatever I decoded, right? If I want to do other things, if I wanted to do let a equals 2 plus 4 and just console log it as well, I can. So I can just play around however I want inside Cartesi, and I can do whatever I want here. I can run a full game engine like you just saw with Rives, or I can run an AI model. I can run complex mathematical computations. I can run a full marketplace, whatever you want to do, really. You're free to do whatever you want. And as you can see, I'm just coding here with JavaScript. So it's really that easy and that immersive. You can just import libs, import tools, and feel free to do it. And that's it. That's the showcase, the speed run on Cartesi. What it is, a good example, and how you can develop with it.
That's amazing, man. Like, I'm not gonna lie, and every time that you're, for example, like you're working with that example tutorial, when you run the code, do you have to pay any gas to have that code execute, or is that all like locally sandboxed?
For the tutorial, is completely sandboxed. The way it's running now, it's emulating the Cartesi machine on the web browser. We can actually put the whole Cartesi machine in the web browser, but it's just an emulated version for now.
Yeah, for sure, for sure. And yeah, I guess you showcase people like all these amazing capabilities of Cartesi. Are there any SDKs, frameworks available for developers to easily get up and running with
Yeah,
Cartesi?
there is. We actually developed the CLI team developed an amazing CLI for Cartesi where you can bootstrap different apps from templates. So you can already have a head start, just like the template I showed in JavaScript. You can have a head start with Python, Ruby, C++, Java, TypeScript, Rust, Go. I don't know if I mentioned them already or I'm already repeating, but so many different languages that are already available for you. And this SDK allows you to run your apps locally. You can send inputs. You can emulate sending inputs. You have the whole environment running on your machine based on Foundry, right? But it's all ready to go. It's just a simple command like Cartesi create. You create a template. Cartesi run. You will run your app, and then when it's everything ready, you can just do Cartesi deploy. And there are high-level frameworks for a few languages as well already. We have high-level frameworks for Rust, Go, JavaScript, TypeScript, Python. So they make your experience so much easier, right? They already handle inputs, outputs, asset deposits, lots of different things.
Awesome. Let's see. I want to see if there's any questions from the crowd. Let's see. Lucas asks, are there any plans to add support for Java in the CLI? If not, is it something that he could do himself, somewhat easily? He's a Java dev.
It's something that you could do yourself, but it's already supported on the CLI. It's very easy to do. You can just get a template and see how it works. It just uses a small lib, and you can basically copy the container and just adapt to Java. But for Java, it's already ready. But we're looking for someone to make a Java high-level framework as well. So that could be an awesome thing to see.
Awesome. Great question. Great answer. Prince Nanso asked, what are the possibilities with the Cartesian machine? I guess beyond what you showcased, what are some other applications or things that you think maybe be cool for a Cartesian machine to run?
Oh man, there was this project that was happening where it was an automated market maker. I really wanted to see something like that coming up again, right? Because with the complex computations that you can do, you can play around with assets to a different level, to a different granularity. There was a project that we saw in a hackathon that halted, but it was really cool as well, which was a high complexity governance solution. So you could have like quadratic voting and different waves for votes that would be possible in Solidity, but would be so much harder to do and so much more expensive to do. So yeah, I think those are two that are on the top of my mind that I really wanted to see. And an MMO game, I would really want to see that happening as well.
That would be cool. That would be cool. Maybe it's something you build, Prince Nanto. There you go.
Yeah. Please do.
I mean, yeah, I mean, the holidays, some people like to build, even though you should technically really rest. But yeah, why not? Why not take a stab at it? Um, yeah, and as we're kind of approaching time here, just got a couple more questions for you before we let you go. Um, can you share anything in the roadmap for Cartesi, perhaps coming up in 2026? Anything exciting
Yeah,
you can reveal?
yeah. We're developing the new version of the SDK, the Node V2. It's gonna have a much more interesting developer experience. First thing is now it's going to include our fraud proofs algorithm, so your computation will actually be proven, right? It's going to be verified, right, through our fraud proofs, which is very nice. So you do inherit Ethereum security, and it does come with lots of new convenience features that are really cool. So before we used GraphQL and JSON RPC, and now we're kind of unified in JSON RPC. So it's more straightforward. Web3 developers have a better understanding of it. They're quick to get on the get-go, which is really nice as well. And yeah, some things that are going to be able to, people are going to be able to follow their computations, like they're going to get instant confirmations on their applications, but they will also be able to follow up the disputes from our fraud proofs, which is really cool. And oh, and there are some apps that I'm really looking forward. People are discussing some apps to build, and I'm looking really forward to see them coming to life.
Amazing. Yeah, sounds like a lot of exciting stuff. And
Yeah.
yeah, we'll be on the lookout for all that. And for the developers and audience members here who are interested in getting started with Cartesi, what's the best way for them to do that? Where would you recommend they start?
I think they should always take a look at our Discord. We are an open source project, and we are open source to the level that even our discussions are in the open, right? So we have a whole R&D section on Discord that anyone can follow, where we actually discuss the next steps. We discuss how we're going to do things and what are the best strategies and best approaches, right? So follow us on our Discord and participate and engage on the discussions, because that's where the things happen. And of course, our X is also very active. Thanks for our awesome marketing team. Then, yeah, I think those are the two key places.
Excellent, excellent. Yes, and we'll have that information for you in the description below of wherever you're watching and listening to this podcast today. And with that, just want to thank you so much, Joao. It was a pleasure having you on the show, learning all about Cartesi. It's really cool. Like, I'm a nerd myself, and I was kind of nerding out when you start the show Doom on Chain. Like, oh my gosh.
That's really nice,
Yeah,
right?
yeah.
That's
Um,
insane, actually.
yeah, exactly. But yeah, just want to wish everybody a very happy Wednesday. Happy rest of the week. Happy holidays for folks. And yeah, we'll catch you back here for another great episode of DevNTell on Friday. But yeah, Joel, thank you again. I really appreciate you taking the time out of your day to join us today.
Thank you so much for having me here. This was awesome, and yeah, happy holidays to everyone.
Awesome. All right, all. Have a good one. Cheers.